in your notebooks, on the next page, let's write the distributive property. Now, what does it mean to distribute? If you distribute something, what do?
Get rid of it?
Get rid of it, pass it out, or something like that. Okay, with the distributive property, we're going to look, the problems look like this. Eight times a quantity, 7 plus 3. Okay, so write that problem down in your notebook. And now what we're going to do is we're going to distribute the 8 to the other numbers inside of the parentheses. Now, or in the past, we did order of operations. We would do what's inside the parentheses first. But the distributive property allows us to do something a little different whenever it looks like this. Okay, so what we're going to do is we're going to distribute the 8 into both parts. And so what ends up happening is we're going to take 8 times 7, and then we're going to add that to the quantity of 8 times 3. And so now 8 times 7 is 56. 8 times 3 is 24. And now when you add them together, you end up with 80. If we have something like this, 3r times a quantity, 4 plus 5. We can distribute the 3r into both parts. So what ends up happening is we take 3r times 4 plus 3r times 5. Now when we do this, 3 times 4 is 12, so that gives us 12r plus 3 times 5 is 15, so that gives us 15r. And now we could add these together, and this gives us 27r. If we have something like this, 5 times 2r minus 6. We're going to distribute the 5 into both parts. So that's going to give us 5 times 2r minus the quantity of 5 times 6. So now 5 times 2 gives us 10r minus 5 times 6 is 30. Now, since this has a variable and this does not, we can't combine them. Here they had the same variable, that's why it allowed us to combine them. Okay? Questions about that?
Wait, how are you supposed to find your answer?
you can't at this point. We would need to know more information. But this is using the distributive property at this point, yes.
Wait, so if that was adding, could you do it or no?
No, you still couldn't. Because here you have a variable, we need to know what the variable is first to multiply the 10 times whatever the variable is, and then take that answer minus 30. Okay? The reason we can combine these because we know, since they're both R, they're the same variable, they're what we call like terms, that's why we're able to combine them together. Yes?
But if you did take 10 R.
You can't do that.
But if you did.
You can't do that.
20 R.
You can't do that. Because order of operations tells us you have to do the multiplication first. Okay? Now, that's the first part of the distributive property.
I'm gonna have exponents for this.
No.
Yeah.
The second part of the distributive property, okay? Let's draw a line here so we know that this is the second part. If we have (16 plus 12), we can also factor out. Now, what is the greatest common factor of 16 and 12? What's the biggest number that we can divide both of them by? It is 4. Think about what can we divide 12 by. We can divide it by 12. We can divide it by 6. We can divide it by 4. We can't divide that by 12. We can't divide it by 6, but we can divide it by 4. Okay? So now, what we're going to do, since we can factor out a 4, we're going to write this down. Factor out 4. So now, when we factor the 4 out, what is 16 divided by 4? 4. What is 12 divided by 4? 3. Now, if we go back to it, we distribute the 4 in. 4 times 4 is 16. 4 times 3 is 12. Okay? Yes. We'll get to that point. We'll do one like that. Okay? We want to find the greatest common factor. Okay? Now, let's go with a little bit with that instead. Let's say we have 36 plus 40. Actually, let's go 36 plus 45. Nah, I'm sorry. Changing my mind too many times. Let's keep it at 40. Now, what can we divide 36 and 40 both by? Owen? 2. Okay? Now, if we factor a 2 out, what is 36 divided by 2? 18. What is 40 divided by 2? 20. Now if we look here, we have 18 and 20. Is there anything we can divide 18 and 20 both by? Steph?
Divide 18 by 3.
By 18 and 20, you have to be able to. Hayden? We can divide them both by 2. So what I'm going to do, this 2, you don't need to draw the line, but I'm drawing the line so you're aware. This 2, I'm going to bring over there. This 2 is going to come from this. Now, 18 divided by 2 is 9. 20 divided by 2 is 10. Now, what is we need to multiply the 2 times 2. Obviously that is 4. And so when we factor out 4 times a quantity, 9 plus 10. So now if you check it, 4 times 9 is 36, 4 times 10 is 40. Okay? So if you don't factor out the greatest common factor the first time, it's not the end of the world. You're just going to need to be able to factor it out. You're going to need to be able to do a second set of factoring. Okay? Does that make sense? Now, let's say we have this. 12x minus 24. Now, what can we divide 24 and 12 both by? We can divide them both by 6. So if we factor 6 out, 12 divided by 6 is 2. Now that leaves us with 2x. We're not getting rid of the x. Okay? What's 24 divided by 6? 4. Now if we look, can we factor anything with the 2 and the 4? We can divide them both by what? 2. So I'm going to bring this 6 over here. Now I'm going to factor 2 out. 2 divided by 2 is 1. So I'm just going to call that x. Instead of saying 1x, I'm just going to call that x. Okay, that makes sense? Minus 4 divided by 2 is 2. And now we have 6 times 2, which is 12. So we have 12 times the quantity, x minus 2. Yes?
So we wouldn't take 12 minus 2.
What do you mean 12 minus 2? Sarah? Where do you get the 12 minus 2?
Well, first we started with 12x.
Minus 24. We factor the 6 out. Okay, 12 divided by 6 was 2. That's how we got the 2 out. 24 divided by 6 is the 4. But then we still had a 2 and a 4, and we could factor 2 more out of it. Okay? 2 divided by 2 was 1, which we could put the 1 here, but you don't need to. And then 4 divided by 2 is 2. So if we go back to our original problem, Elwin, we could have factored out a 12. 12 divided by 12 is 1. 24 divided by 12 is 2. Okay? Question about that?
But then we only have a 2.
What do you mean?
When you divide it by, wait.
We're going to do some more practice, okay? Just hold on, okay? Now, the distributive property can be used for a third reason. It can be used when we are multiplying 2-digit numbers. Let's say we have 24 times 16. Now, whenever we want to do it to multiply two numbers, two-digit numbers, or a 2-digit number, the first thing we're going to do is we're going to break one of the numbers into expanded form. Okay? So, if I take 24 and I break 24 into expanded form, it would be what?
6 and 4.
No, expanded form.
20 plus 4.
20 plus 4. So 24 breaks into 20 plus 4. Okay? Does that make sense, what we did so far? Now, once we do that, now we're going to take the 20 times the 16 and then take the 4 times 16. I feel like there's a spider crawling up my leg or an ant. Probably a fly. Now, if we had 24 times 16, we've got to break into 16 down into expanded form, which would be 10 times 6. Or 10, sorry, 10 plus 6. Sorry about that. So now, if we break the 16 into expanded form, now it would look like this. 24 times 10 plus 24 times 6. Okay. And then the last way that we can use a distributive property would be to have, let's say we had this. 30 times 23 plus 6 times 23. Now, if we look at that, it's just a string inside my pants. If you look at our problem here, based on the pattern we've had up here, which of these numbers has been broken into expanded form? Well, let's change it around. Let's make it an easier question. Which number is the same in both quantities?
23.
23. So if that number is the same, that number obviously was not broken into expanded form. What number was broken into expanded form? Wyatt?
30.
30 and? Landon? 6. Making what number? 36. And so, if we put it back together, we would have 36. 30 and 6 makes 36 times 23. Okay? So, we have a whole lot of different things that we can use the distributive property for. Okay, we can factor in. We can factor out. We can solve a two-digit multiplication problem by breaking one of them into expanded form and then multiplying each of those parts of the expanded form times the other number. Okay? When we get back from our class, we're going to practice all 4 types. Okay?
Thank you, because I don't understand this. I sort of.